How can we tell where a function is increasing, decreasing, or constant? All right, well, if you look at the graph, it's pretty easy to tell, okay, the graph is going up here, and it's going down here, and it's going up here. But how do I express that in interval notation? We also want to look at some additional terminology. When your graph changes from increasing to decreasing, that point where it switches is called a local maximum or a relative maximum. It's called that because it is the highest value in its locale relative to what's around it. So how do you think we would get a local or a relative minimum? Yeah, it would be where our graph switched from decreasing going back to increasing again. That value down there would be a local minimum. So if they ask you to find all the local extrema or the relative extrema, they're just asking you to identify those maximums and minimums. Also on your graph, you may have an absolute or global maximum. That is the one highest value on your graph. And then just like that, the absolute minimum would be the one lowest value on your graph. So if I want to express intervals of increasing, decreasing, and constant, I'm going to use interval notation for that. And so when we first look at our graph, we can see that it starts going down. It starts decreasing, and it looks like it decreases to about here. Now, when I go to write my interval, something to remember is that I'm going to use the x values. X tells where the graph is increasing or decreasing. The y values are going to be our maximums and minimums so that we can actually see what is the highest value and what is the lowest value. So for increasing, decreasing, and constant, we are always going to use our x value. So if we're trying to see where this graph is increasing, then let's come over and look at it. We can see right here it's increasing, and right here it's increasing. We're going to express that with x values, okay? So from right here is where it started at +1 to right here is where it stopped at +3. So we're going to say that it was increasing from 1 to 3. Then we're going to see where it started again. That'd be right here at 4, and then it kept on going. So we would say from 4 to infinity. And when we have two separate pieces, we usually connect them with that union symbol. Now, notice that I used parentheses for all of these. Typically, we use a bracket to mean equal to. But you'll notice here in just a second, we're going to look at this and we're going to say this piece is decreasing. And so if I use a bracket for 3, I'm going to say that 3 is increasing and 3 is decreasing. How can it be both at the same time? It's actually not either one. That's where the graph changes from increasing to decreasing. And so we're always going to use parentheses with our intervals of increasing, decreasing, and constant. Okay, so now let's go look at the decreasing piece. So I have a decreasing piece right here. So if you think about the x values, this just keeps going and going and going and going this way. So it's going to be -infinity to +1. And then our next decreasing piece was from 3 to 4. Now, we didn't have a constant piece to this graph, but the way that you would identify a constant piece is if you had a horizontal segment in your graph where your y value was staying constant, it was staying the same. So if I had a horizontal line from 4 to 6, then it would be constant from 4 to 6. All right, then let's identify our local maximums. So remember, the local maximum is where your graph changes from increasing to decreasing, and ours did that right there at 3, 1. Now, if they ask you to give the whole ordered pair, that's fine, but if they're looking for just one value, your maximum or minimum is your y value. That's what tells the high or the low, right? 3 just tells where that happens. So the maximum or minimum is the y value. We have a maximum of 1 that's occurring at 3. All right, then minimums. For minimums, it was where our function changed from decreasing to increasing. So that happens right here at 1, -1. And decreasing to increasing, it happened right here at 4, 1/2. So those would both be my local minimums. All right, absolute maximum and minimum. So for the absolute maximum, we're looking for the one highest y value on the whole graph. Well, if this keeps going to infinity and this keeps going to infinity, then we're not going to have an absolute maximum because that value is going to constantly be changing and getting larger and larger and larger. We can't say that infinity is the maximum because it has to be a y value that you're equal to. You can't equal infinity. Infinity is a symbol that represents something getting larger and larger without bound. So I would not have an absolute maximum. Do I have an absolute minimum though? Well, yeah, this 1 point right here is lower than all the rest on the graph. So we could say that we have an absolute minimum of -1 and it occurs at +1. So that would be the point 1, -1. Now, if instead of having arrowheads on the end of these, what if we had had an endpoint on both of these? Would you then have had an absolute maximum? Well, yes. One of these values, if one was higher than the other, would have been your absolute maximum. So if your graph has endpoints, you will have an absolute maximum and minimum. If we had added endpoints, we would have ended up with an absolute maximum, and we already had the absolute minimum. But if your graph does not have endpoints, which ours didn't, you may or may not have an absolute maximum or minimum. So we had a minimum, but we didn't have a maximum. You might not have either one. All right, let's look at another example. All right, so again, let's go through and identify all of the things that are asked for here. If you want to pause the video and identify that on your own and then check your work, you're welcome to do so. So if we're looking at the function, let's start with increasing and decreasing. Remember, you're using x values, all right? So the first x value that we have is right here at -2.5, and it increases to -2. Then at -2, it starts decreasing, and it decreases to 0. So decreasing -2 to 0. And then it starts increasing at 0, and it increases to 2, because remember, we're using our x values, not our y values. So it increases from 0 to 2, and then it decreases from 2 to 3. All right, so these are those same intervals we just mentioned. Remember that we're only giving the x values in our intervals, and we're always using parentheses. If we have more than one value, we can use the union symbol to unite our two intervals. All right, then local maximums. Remember that a maximum is where your graph changed from increasing to decreasing. So right here, we changed from increasing to decreasing. So that would be a local maximum or a relative maximum at -216. Then we change from increasing to decreasing here at +216 as well. So that also would be a local or a relative maximum. All right, local or local or relative maximum. To find our local or relative minimum, it's where our graph changes from decreasing to increasing. So that would occur at 0, 0. 3, -10 cannot be a local minimum because go back to your definition. Your local or your relative minimum is where your graph changes from decreasing to increasing. My graph is not changing there. I don't know what it's doing. I don't know if that's going to be the lowest point relative to what's around it if that graph continues going. So you can have an absolute maximum or minimum at your endpoint, but you cannot have a local or relative maximum or minimum at an endpoint. All right, so the absolute maximum, the absolute highest point on this graph is at negative 216 and positive 216. Wait, how can we have two absolute maximums if it's the one absolute highest value on the graph? Because again, what is your maximum? Is it your X or your Y? It's your Y value. It can occur at multiple places, but my maximum value is 16. It happens to occur at negative 2 and at positive 2, but it is one absolute highest value. All right, then what's our one absolute lowest value on the graph? Well, it's right here at negative 10. So our absolute minimum would be negative 10, and it occurs at x is equal to 3. And we could write that as the ordered pair 3, negative 10.